So the question that usually comes from doing problems like this is, though that took a long time to find all those derivatives, I had to find 7 derivatives just to build my polynomial and then evaluate them here in orange in order to get my coefficients. With the AP exam asking me to do that. And the answer is sometimes, but they wouldn't ask you to go all the way to 7th degree. They might ask you to go to like the 3rd degree or the 4th degree. But sometimes they have maybe more novel ways for you to set up your Taylor polynomial, like example number 3. We have a table of values. It's giving us functions and derivative values at this particular x point. So it says function f is differentiable for all orders of n, and it has the following derivative values when x equals 1. Find a 3rd-degree Taylor polynomial for f of x centered at x equals 1. That means that this and this and this, all these c values are going to be 1. So how far do I need to go? I need to go to the 3rd degree. That means I need 3 derivatives. Well, my table is showing me 3 derivatives, so I can create my polynomial without too much hassle. I need to find f of 1 added to f prime of 1 times x minus 1 plus f double prime of 1 divided by 2 factorial times x minus 1 squared plus f triple prime of 1 divided by 3 factorial times x minus 1 cubed. Do not write anything else. We don't need to write the nth term. Since the problem specifically asks us to find a 3rd degree, I should not write anything more than this. No more terms. Can we evaluate? Oh, we can definitely evaluate because f of 1 is 2 plus f prime of 1 is negative 3 plus f double prime of 1, that's 1, plus f triple prime of 1 is negative 6. Here is our 3rd-degree polynomial, and I didn't have to do as much work because somebody had already found my derivative values for the first 3 derivatives, which was exactly what I needed. My claim is that if I create this polynomial, it will match my information given to me about this function, which technically I don't know what it is. Okay. Example 4, can we write a Maclaurin polynomial using just known information, whatever is given to me without graph, without function, without taking derivatives? We're looking for a 3rd-degree. That means the farthest I need to go, P of 3, is going to be f of, now we're looking for a Maclaurin polynomial. That means we're centering at 0, plus f prime at 0 times x minus 0 plus f double prime of 0 times x to the 2nd power plus f triple prime of 0 times x to the 3rd power. And I should stop there. Don't write any more because it was specifically asking me for the 3rd degree. So I can stop. But now, how do we figure out the actual values? Well, they told me. Well, I guess in this case, it wasn't f, it was g. So all of these f's that I wrote should be g function, since we're using the g function to find these derivative values. So g of 0 we know is 2, plus the first derivative at 0 is negative 1x, plus the second derivative of 0. Now it says, and for n's that are greater than or equal to 2, we now use this formula. So this formula says if you want to find the second derivative at 0, then just use this formula to figure it out. So I'm just going to write it the way the formula says. X squared plus 3 cubed over 3 factorial times x to the 3rd. Here is my 3rd-degree polynomial that we're looking for, and that's going to help me approximate whatever the g function is. I can approximate as long as my x values are pretty close to x equals 0, since that's my center. I can figure out a pretty good approximation for that function g. So the purpose of the polynomial is to approximate g of x. g of x is the original function, p sub 3 of x is the polynomial that approximates the original function.